Welcome! In today's lesson, we're going to explore the notion of matrices in detail. Matrices are fundamental objects in mathematics, especially in linear algebra, and have wide applications in various fields. So, what exactly is a matrix? A matrix is a rectangular array of numbers, symbols, or expressions arranged in rows and columns. Think of it as a grid or a table of mathematical values. In mathematics, we usually denote matrices with capital letters such as B or M. The individual elements inside a matrix are typically represented by lowercase letters with two subscripts, indicating their position. For example, a sub-ij represents the element in the ith row and jth column of matrix A. A key characteristic of any matrix is its dimension, which refers to the number of rows and columns it contains. A matrix with m rows and n columns is called an m by n matrix, written as m times n. For example, this is a 3 by 3 matrix because it has 3 rows and 3 columns. There are several special types of matrices that we commonly encounter. Let's look at some of the most important types. A row matrix has only one row. A column matrix has only one column. A square matrix has the same number of rows and columns. A zero or null matrix contains only zeros. In a diagonal matrix, all elements outside the main diagonal are zero. And an identity matrix is a square matrix with ones on the main diagonal and zeros elsewhere. Now, let's discuss some basic operations we can perform with matrices. First, matrix addition. We can add two matrices if and only if they have the same dimensions. To add matrices, we simply add their corresponding elements. For example, if we have matrices A and B, the ijth element of their sum C equals a sub ij plus B sub ij. Next, scalar multiplication. When we multiply a matrix by a scalar, which is just a regular number, we multiply each element of the matrix by that scalar. For instance, if we multiply matrix A by scalar k, each element a sub ij becomes k times a sub ij. The most important and complex operation is matrix multiplication. Unlike addition, matrices can be multiplied only if the number of columns in the first matrix equals the number of rows in the second matrix. The multiplication process involves taking the dot product of each row in the first matrix with each column in the second matrix. Let's see an example. When multiplying a 2 by 3 matrix with a 3 by 2 matrix, we get a 2 by 2 result. Each element in the result is the sum of products of corresponding elements from a row of the first matrix and a column of the second matrix. Matrices have a wide range of applications across various fields. In mathematics, they're used to solve systems of linear equations. In computer graphics, matrices help with transformations like rotations and scaling. In physics and engineering, they represent physical quantities and transformations. In economics, matrices can model economic systems and input-output relationships. And in cryptography, matrices are used for encryption and decryption algorithms. In summary, matrices are powerful mathematical objects that allow us to represent and solve complex problems in a structured way. They're defined as rectangular arrays of elements with specific notations and dimensions. We've explored various types of matrices, basic operations, and their wide-ranging applications. Thank you for watching this comprehensive introduction to matrices. Remember that mastering matrices is essential for many advanced topics in mathematics and its applications across different fields.